Hello and welcome to this explanation of the work that we presented for the symposium A1. This is poster PO46 and this is the team that worked on this project, and I will present very quickly the main results of this project. So we worked with structures called semi-fullerenes that were obtained by cutting in half a full C60 fullerene, and we then explore the interaction that these fullerenes would have in sheets of graphene. So here we have two different structures depending on the shape of the base that was obtained when cutting the whole graphene in half. So we could obtain an hexagonal base, which is this case here, or a pentagonal base, depending on how the slice was made. And so we have a semi structure that will be called C30 because it's comprised of 30 carbon atoms. And here we present the structural relaxation that was performed on these two structures. As we can see here, we use the Quantum Espresso package. These are the parameters that we used for the calculations that were static, and the cutoff energy was 80 Rydbergs. So for every absorption energy that we report here, this is the definition that we used in the poster. We show the source for that definition, and basically is the system, the energy of the combined system minus the energies of the individual systems before they interact. So after we obtain a relaxed structure for each of the two semi-fullerenes, we made them interact with the graphene sheet that was originally comprised out of 50 atoms, but we removed 6 of them from the center section of the unit cell to create a vacancy, and so we let the semi-fullerene interact with the vacancies, as we can see here. So this is the relaxation results. For both cases, we observed that the semi-fullerene is absorbed by the structure. After that, we started saturating the system by including one lithium atom at a time, and then letting it relax and observing how many lithium atoms we could add before any clustering was observed. So in the case of the first structure with the hexagonal base fullerene, we observed that the system can absorb up to 16 lithium atoms before clustering, and the absorption energy per lithium atom is minus 1.4 electron volts. And here we present the density of states plot for only some selected atoms, as you can see here. And finally, we repeated the structural relaxation for this second structure, for the pentagonal base semi-fullerene. And again, we observed that this system can absorb up to 20 lithium atoms. This is corresponding to an energy per lithium atom of minus 2.02 electron volts. And finally, we have here the density of states plot. So this is a very good ratio of absorbed lithium atoms per carbon atoms, as we can see here. And this could be used for either storage or sensor applications. Thank you. And well, here are the references. And here is the way of contacting us for any further doubt or inquiry that you may have. Thank you for your attention, and that will be all.